Well, it's 12 Eastern time, so excited to get started. My name's Jordan Swaim Fox, and I'm the Outreach Coordinator for the Center for Urban and Regional Analysis, or CURA, at The Ohio State University. I'm really excited to welcome you all to our first event of the webinar series, Climate Lessons for Our Cities, Global Perspectives on Climate Change and Urban Environments. This series is co-sponsored by CURA and the Byrd Polar and Climate Research Center. And throughout the series, we'll hear from international scholars and practitioners about the impacts of climate change on cities and the best ways to mitigate and adapt to these effects. So today's guest, Dr. Rajashree Kotharkar, will provide an overview of the Heat Action Plan as a tool for planning and managing extreme heat, the increasing challenge of heat in cities, and courses of action for urban planners to tackle heat-related challenges. Before we introduce Dr. Kotharkar, I want to mention a few housekeeping items. If you require closed captioning today, you'll find a box at the bottom of the screen labeled with CC. Click the box and select Show Subtitles, and this will allow you to view the subtitles during the presentation. During the webinar, feel free to submit questions at any time using the Q&A box. We'll ask as many of the questions as we can in the last portion of the presentation, and if we don't get to your question, apologies in advance. You'll also notice that chat has been disabled, so please use that Q&A function if you have any information that you want to share with the organizers. As you might have seen on our website, this event is approved for 1 AICP CM credit, and to claim this CM credit, you can log into your My APA account on the APA website and enter the event into your online CM event log. There'll be a brief survey at the end of this webinar, so if you have time, I encourage you to provide your feedback. That really helps us improve these events, so I'd love to hear from you. If you have any additional questions following this event, whether it's about credit, the webinar itself, please don't hesitate to reach out to me at swaim-fox.1@osu.edu. To learn more about CURA's future events or to sign up for our monthly newsletter, visit cura.osu.edu. And you can also like CURA on Facebook and follow us on X, Instagram, and LinkedIn. To learn more about the research of the Byrd Polar and Climate Research Center, including all of their public programs, visit byrd.osu.edu, that's Byrd with a Y, or check out their social media streams on Facebook, Instagram, X, and LinkedIn. And with that, I'll pass it over to CURA's director, Harvey Miller, to introduce himself and our speaker for today.
Okay, thank you very much, Jordan, and welcome to our Spring 2024 series on climate lessons for our cities. I want to welcome you on behalf of CURA and also on behalf of the Byrd Climate, Polar, and Climate Research Center and Jason Cervenak, who's on the webinar. I have the pleasure today of introducing Dr. Rajashree Kotharkar, and she is an architect urban planner and a professor in the Department of Architecture and Planning at Vishweshwara University. I'm sorry about that. I practiced beforehand, but I blew it. University in Nagpur, India. She works in the realm of urban environmental research, exploring the impacts of urban morphology on heat stress distribution, outdoor thermal comfort, heat risk perception, heat vulnerability, and sustainable urban development. She has completed multiple research projects funded by national and international funding agencies, such as the Department of Science and Technology of the Government of India, World Bank, and the American Red Cross. Her current work focuses on heat wave studies, developing and implementing intervention policies for urban heat risk management and adaptation. She is an expert committee member for the review of the National Disaster Management Authority guidelines on heat wave preparedness. She is also an energy conservation building code trainer and part of the expert committee in State Disaster Management Authority of Maharashtra and National Program on Climate Change and Human Health. And she's not on camera right now because we're going to try to preserve the bandwidth for a more stable internet connection. So I'll just mention that so you understand she's not being rude. We're just trying to preserve our bandwidth here. And with that, I will turn it over to Dr. Kotharkar.
Thank you so much. I'll share my presentation now. And I think it's visible now. Can you hear
Yes.
me? Yeah. Okay. So we are going in the slideshow mode. Can you see the slideshow now?
Yes.
Yes. Okay. Thank you so much. My thanks to the Ohio State University and Byrd Polar and Climate Research Center, as well as CURA, for inviting me for this. I'll be sharing my experience throughout the research that we have done for last more than a decade, maybe last 10 to 12 years. Just to give you an idea as to what kind of research we do, it is mostly field study based, less emphasis on simulations, and we take help of satellite imagery, but mostly going to the field, talking to people, taking measurements, stationary data, as well as we conduct traverse surveys. You can see the vehicle there. On top of that, we put up the sensors and run around, drive around the city to see what is basically to study the urban heat concerns. And so that's how, so just to give you a background, this is the way the study is done in our lab. I'm going to talk about, today's talk would have four components. First would be talking more about what heat action plan is all about and how does it get connected to urban planning. Secondly, I'll just show you a few things related to Nagpur, which is a case study of Tier 2 city in India, where we have conducted our study, and the mitigation measures that we have tried to simulate there. And lastly, what is the road ahead for us as urban planners? So heat wave essentially is kind of defined as in terms of intensity, frequency, and duration. And it depends on the local threshold that one has. So in India, it's like 45 degrees Celsius for the plainer regions. For coastal areas, it's 37 degrees Celsius. And for hilly regions, it's 30 degrees Celsius maximum temperature. Heat waves are supposed to have impact on energy consumption. They damage infrastructure. There is an excessive mortality. There is damage to the health. It has an impact on productivity. It has an impact on economics. And many of these things have not been studied in great detail. Urban heat island, which is heating up of cities as against their countryside, rather warming up of cities as against their countryside, is a phenomena that is very well known. But it is supposed that it kind of contributes to the heat wave as well. And the cities experience daytime heat island effect, and they also have nocturnal heat island effects. If we look at the whole world since 1980, we have seen a lot of major heat waves in the world, and some of them are just listed here. The area that is shown in red color is the region which has experienced major heat wave. There are areas, geographic areas where we do not have much data as well, and so one cannot say about that. If you say what kind of progress we have made in the heat management area as far as the cities or districts, or for that matter nations or states are concerned, it started in 1995. That's the first heat health warning system that we know of. And since then, we have come a long way. In 2008 rather, the WHO came up with a guidance book, a book that guides people to prepare heat health action plans. And it listed what should be the what kind of structure HHAP should have, what should be the components, how should it be prepared, what requires to be done, everything was listed. But it took a long time. Even today, we don't have the heat health action plan the way WHO essentially proposes to have. So in 2021, it was updated as well. But there is a lot of progress that the world is making in heat management. Heat action plans are currently, they are the only framework which is available with us. And they take care of, they are an effective tool. So they're supposed to identify heat vulnerabilities and also identify how to address to them through adaptation and mitigation measures. Some of these principles that WHO has proposed, or rather is talking about while preparing the heat action plan, three major principles are very critical for urban planners. That adopt a long-term approach is something that WHO proposes. Secondly, it has to be multidisciplinary. It cannot be a peripheral approach, so be broad. And most importantly, any response to through the where you're trying to deal with heat waves should not add to the problem of climate change, which essentially tells us that air conditioning is not a solution when we are talking about mitigating extreme heat or adapting to extreme heat. There are 8 core elements that are proposed by WHO while preparing the heat health action plan. And in this, some of it essentially revolves around devising or designing a heat health warning system, wherein you require an accurate and timely alert system. That means you're required to know the trigger when you want to send a warning. That is one. Second, there has to be a proper health information plan. So the communication has to be proper. And thirdly, it must be able to identify where the vulnerable population lives or which areas in the city are vulnerable and how do you provide communication to them. That becomes a part of heat health warning system. Second part of the heat action plan, which is directly linked with public health, is the working of health and social care system. What kind of health and social care system one should have. From urban planning point of view, there are 2 to 3 aspects that are critical. That is reduction in indoor heat exposure. How can you do that? That is required to be done. Secondly, how do you take particular care of vulnerable groups? So how does urban planner come into the picture that you want to locate the vulnerable groups? That's one. And you also want to identify areas in the city that are vulnerable to heat. And lastly, what kind of long-term urban planning measures can be taken to deal with extreme heat at the city level? The other 3 domains that are also critical to heat action plan are meteorology, because they are the ones who are going to tell the city in advance as to when the heat wave is expected. Epidemiology, because it tries to study the impact of extreme heat on health. And public health, which is trying to deal with extreme heat when it is, while it is going on in the city. Currently, the kind of heat action plans that we have, long-term urban planning is the least addressed of all the domains, which one can see from here that the heat action plans, there are 50 heat action plans that we reviewed. We realized that most of them, 50% of them, there is the long-term urban planning is missing. 6 out of these 50, there is a very weak link between weakly described in heat health action plan, and only 14 of them has some mention of long-term urban planning. What are the concerns that we have today as far as heat action plans are concerned world over? One, we do not have a proper definition of heat wave. In terms of, throughout the world, there are multiple heat wave definitions. So either they are on intensity, duration, what kind of frequency is there, what should be the local threshold, should it be based on local threshold? Secondly, there is a need for expanding the coverage of heat health action plans. Mostly, as is observed in India also, mostly heat health action plans are prepared for cities which are prone to the exposure to extreme heat. But in days to come, I think almost every city would have some kind of exposure to extreme heat. Some issues which are concerning the urban planning as well, that is heat vulnerability mapping is not being done for cities. And even if it is done, it is static. So if it is being done for Nagpur, say 2022, you have a heat vulnerability map with you. But if you take certain measures, how does the vulnerability mapping change? We have no idea. The other thing is most of the heat health action plans are being prepared in isolation. They do not get integrated with the national planning policy or the development plan that is being made for the city. The third thing is water, which is one of the most critical component of the solution, which is associated with extreme heat, is not being integrated with the heat action plan. And large part of this world is also experiences water stress during extreme summers. So one can say that something which is a solution for the heat is also a problem during extreme heat. And that requires a lot of attention, which currently nobody is talking about. Fourthly, most of the heat action plans we have are public health centric. There is a complete neglect on a lot of other sectors like economy, energy, infrastructure, productivity, informal sector, housing, a lot of other sectors, transportation for that matter. Lastly, there is no periodic monitoring or evaluation of heat action plans for us to know whether the measures that we were taking, whether they're adaptive measures or mitigative measures, whether they worked or they did not work, what is required to be done, we have no idea. There is this debate, rather, which I strongly talk about, is currently what we are doing is heat management. Against what we require is extreme heat planning for extreme heat. So some of the aspects which are required from extreme heat planning point of view is talking about urban heat islands, studying them, trying to understand their impact on the heat stress in the city. Secondly, trying to understand the role of various adaptation or mitigation measures. Currently, you will only see cool roof and cool pavements being given a lot of importance. A lot of other measures are not being studied, or very limited understanding is there about them. Lastly, how does the urban form modification affect the heat planning that requires to be studied? So the FSIs that we change, or the urban form that changes in the city, how does it affect the microclimate, especially heat from heat perspective? And lastly, as I said, that urban planners, it is mostly urban public health perspective, and it requires other domains to come into the picture. Since I'm going to talk more about India and our studies in India, I thought I'll give you a brief idea about the extreme heat scenario. So we've been experiencing it. I mean, something that we have documented 2010 onwards, there have been a lot of heat wave days. Every year, or rather every 2 years, you'll see more number of districts being added uh, to the geographical area, which is considered as prone to extreme heat. So the geographical expanse of the areas exposed to extreme heat is increasing every year. What kind of progress is India making in heat management? The first heat action plan was prepared by the Odisha state in 1996. In 2013, India had its first heat action plan for the city, which was made for Ahmedabad. And over last so many years, there have been multiple heat action plans prepared at the city levels, district level, and state level as well. And in 2023, we've come up with this handbook, which is kind of a framework for a model heat action plan. So this can be used by cities to prepare their own heat action plans. Just to give you some background of what kind of urbanization trends India has, I am presenting an old data though. So most of the population in 2011, you can say that a large population, that is 42% population, was living in cities that are million plus. So there is a class 1 cities which are million plus cities that do not include the mega cities. These cities, there is maximum growth in these cities, and most of the population lives in these cities. And Nagpur falls in this particular category. And personally, I feel that there is a lot of hope for these cities because they have a high growth rate. At the same time, they are shaping, if we come up with new models, if we come up with solutions or mitigation measures to deal with the cities, I think, and if they are implemented in these cities, we have a brighter future. Nagpur lies in the center of India, and it is kind of 2 million plus population with tropical wet and dry kind of climate, with dry summers from March to May, and June, July, a part of it is pre-monsoon, is considered to be warm and humid. So it kind of experiences dry heat waves during the March to May, and sometimes it does have these humid heat waves during June and July. I'm going to run through this as an investigation where we tried to use the local climate zone classification mapping for Nagpur. And this classification is used to map urban heat island intensities, to map local thresholds, to understand what is the heat risk or heat hazard level across the city using LCZ classification. And for the mitigation also, LCZ classification is being used. So it's kind of a case study which tries to understand what is the impact of heat and what are the morphological parameters that are possibly responsible for the increase in temperature, and what kind of measures are possibly can work in Nagpur. So it is a complete, small but complete package. So LCZ classification was proposed by Stewart and Oak, and I think many of you must be knowing about it, so I'm not going to dwell in it too much. So it essentially is based on it's a new kind of a land use land cover classification, which takes into account morphology, urban form in terms of height, in terms of building density, vegetation, the kind of vegetation that you have, the kind of land surface you have, and based on that, there are 10 built-up classes and 7 natural classes. And typically in India, where you have a very high density and heterogeneous kind of urban morphology, we have used subclasses as well. That means one particular LCZ is nested in another. So if there is a LCZ3 and you see a part of LCZ7 in it, you call it LCZ37. This is the LCZ classification for Nagpur. And cities like Nagpur with the similar populations and similar size, you can say, are most predominantly have a very high percentage of LCZ3, that is low rise, high density. And secondly, the LCZ9, which is essentially the fringe area of the city where you have sparse development. So these are the two classes that are very predominant in cities like Nagpur, and their subclasses as well. So what we tried to do here was we tried to understand that if you have various LCZs, this is a study based on some 80 days of hourly temperature data during the summer of 2022. And so this is something that you see is a group mean and how is each LCZ placed with respect to the group mean. So we can see that if you see the nocturnal UHI, if we call it UHI or intra-UHI, the areas with high built up are the ones which are extremely warm, and you can see that, and high vegetation are the ones which are cooler, and there is a difference of 4 degrees between the two. Whereas during the daytime, it is the high built up areas, that is the core of the city, which is cooler, and the sparse built up, which is the fringe of the city, is warmer, and the difference comes out to be close to 3 degrees Celsius. If the same thing is mapped, you get a picture like this, where during the day you have the fringes, extremely warm fringes, and as you start entering towards the city core, it's much cooler. Whereas at night, it's exactly the other way around. The LCZ3 is quite warm. As you start going away from the city, it's relatively cooler. The difference, so that is the deviation from the mean. When you look at the same thing from the heat index perspective, heat index is a composite index where you have temperature as well as relative humidity. And you also consider the urban heat island, that means just the delta T. One realizes that there is a variation that one can see, and LCZ9, which is a sparse development, can be considered as the most critical of the LCZs. The other analysis which we did was for the local threshold. The local threshold is essentially at the temperature, whether maximum temperature, we have done it for minimum, maximum, and mean as well, where the all-cause mortality, so we've done it, we mapped the all-cause mortality against the T minimum, T mean, and T maximum. And so we wanted to know a point beyond which the all-cause mortality starts increasing. I mean, really, that's a point of deflection. That beyond that, now there will be a lot of deaths. So in T minimum, we realized that it came out to be 30 degrees Celsius, and T maximum, it was 42 degrees Celsius. What we tried to do later on, this was done using some 15, 16 years of all-cause mortality and meteorological data. What we did later on was map it. I mean, we took the data, the LCZs, and tried to see which LCZs have a tendency to go beyond the point of deflection. So Tmax, you can see that LCZ9, that is a fringe, 9.3, that means LCZ nested in 9, LCZ3F, where the LCZF is nested in 3, and LCZ8 are the ones which have a presence beyond this 42 degrees Celsius, which is a point of deflection. And in case of T mean, it's essentially the core, which is the LCZ3, which goes beyond 30 degrees Celsius. So this is the variation that you see in T max. This is where you can see that at the variation that you see in T minimum. This is the point of inflection that you have in case of the minimum temperature. So these are the areas that have a tendency to go beyond 30 degrees Celsius at night. So though I mean, the point that I'm trying to make here is, though we know that when you have a maximum temperature which goes beyond 40, you essentially will have a warm night. But there will be areas within the city which do not go beyond 40 degrees Celsius during the day, but they would have extremely high heat stress during the night. So the city, there is a possibility that the city has a different pattern of heat stress during the day and a different pattern of heat stress during the night. And that's why this point of inflection with T minimum and T maximum, both of them have their own merit or their own importance. So what we essentially found out was that two types of LCZs are extremely critical. One is LCZ3 and its subclasses, because they have a very high nocturnal UHI and a high heat hazard during the night, because we are considering nocturnal temperature, I mean the temperature during night also as a definition for heat hazard. And during the day, the 9 and its subclasses have a high possibility, or rather, they have a high daytime UHI, and they also have a high heat hazard. And so 3 and 9 and their subclasses become very, very critical. And it would be interesting to know that we have mapped LCZ classification for 15 to 20 cities in India. And in the same, you can say the same category. And we realized that most of the city, it's LCZ3 and its subclasses and LCZ9 and its subclasses account for 30 to 35% of the city in this category. So you can imagine that this 35% of the city will be perpetually in the heat stress in these LCZs will always be in heat stress during the extreme heat event. Since the critical LCZs were already identified, we tried to see whether the mitigation measures that we know of, that is cool roof, cool pavement, planting trees, or increasing green area ratio, do they have an effect, and what kind of effect would they have on the three critical LCZs, that is 3, 3F, and 9. So we conducted this, since you cannot do it through the field study, we conducted simulations using NVMet. And we realized that when you're talking about 3F, it's a combination of cool pavement and trees along the road. When it comes to LCZ3, which is a core area where you have a very high density, is the cool roof. And when it comes to LCZ9, it is increasing the GR that works. So though we know the mitigation measures that are critical for management and planning of extreme heat in the cities, but it is important to know the effectiveness of these interventions, and that it would depend on the morphology of a particular area, and that would require certain amount of background study to support a decision or formulate a policy, maybe that, okay, LCZ3 should then have these kind of mitigation measures. Then we further try to understand if one has to kind of make changes in the development plan, in development control rules rather, and you want to modify the certain parameters of urban morphology, what are these parameters that would have an impact on temperature? So we had taken some 10 parameters. Out of these 10 morphological parameters, the building surface fraction, the impervious surface fraction, the pervious surface fraction, the the vegetation density ratio, the facade density ratio, these were some of the factors that had an impact on the temperature. So if you see that VDR, if you increase the VDR by 10%, it would reduce the temperature by 0.3 degrees Celsius. If you're increasing the, so if there is a certain amount of increase made, certain percentage increase, so that is something that we tried to understand. But that was done independently as to change in VDR, what kind of impact does it have on nocturnal temperatures. So because we all know that collectively they define the urban form of any city. So finally, there are two ways in which one can mitigate the heat. One is you reduce the urban heating. The other part is you cool the cities. So there are only two ways of cooling the city, that you put a lot of vegetation and also go for blue-green infrastructure. For reducing urban heating, you require two things. One is, how do you reduce the trapped and absorbed heat? And how do you reduce the anthropogenic heat? To reduce trapped and absorbed heat, one needs to make changes in land use, land cover. One needs to modify the urban form, modify densities. And to reduce the anthropogenic heat, one should focus on transport, changing the way we deal with urban transport, looking at the energy consumption patterns of buildings and land uses and how we can reduce that. So in a nutshell, if we say that we want to address to extreme heat, then at urban form level, we need to change the urban planning policies. Urban surfaces, we can have cool roof, cool pavements. Urban transport, we need more pedestrian-friendly city, non-motorized vehicles, public transport. Blue-green infrastructure, as I said, we need to increase the urban greening. And at the same time, one can start working at the other spatial levels as well, that is building level as well as neighborhood level. So what becomes very, very critical is the local context is extremely critical. Something that works for a particular local context in terms of climate type maybe. In Nagpur, we saw that since it's a dry summer, temperature mattered more than humidity. But when you see a humid heat wave, the temperature and humidity both will have a role to play. Secondly, it will have to be a multidisciplinary approach. Thirdly, it requires a lot of data, and the data cannot be static. It needs to be dynamic for diagnosing what is happening so that one can take decisions. All spatial scales are critical. That means whether building, neighborhood or city, all scales are critical. All temporal scales are critical. Whether what you want to do in the short-term basis, what do you want to do in the medium term basis, what do you want to do on the long-term basis. In every city, you require a spatial framework. In our case, we use LCZ framework. And one will have to have an hyper-local approach. As I just showed it to you, that across the city, maybe certain part of the city is experiencing heat wave, a high level of heat stress, and the other part of the city does not have the heat stress. The impact is multi-sectoral. That means energy, health, everything is. So mitigation solutions will also have to be multi-sectoral. They can't just be a unidimensional or unidirectional approach. there we will require a predictive application of maybe machine learning based predictive models where you can predict the impact of a certain kind of heat wave on urban forms and try and take measures accordingly and go for mitigation and adaptation measures. Most importantly, heat and water, I always say this, they are interlinked, and water is very, very critical. So urban planning, as I said, plays a critical role in extreme heat management and planning. And I don't think we have really reached there because most of the time, as I said, the way extreme heat is being dealt with is on a short-term basis. It is a single sectoral that you're only focusing on public health, and there is no spatial component to it. And mostly the local context is also missing in most of the cases. That has been my experience. Thank you so much. I think I stuck to the time as well.
Okay.
And I would like to thank all the funding agencies and my team of extraordinary students. Thank you so much.
Okay, thank you very much for a fascinating talk. It's really incredible how not only is it hyper local, but it's also time dependent. And it really says that you have to be very nuanced and intricate and like I said, tailored interventions in order to deal with this issue. When in fact, most of our planning tends to be one size fits all, unfortunately. So that's a really fascinating point. I want to remind the audience that you can submit questions. Just do it through the Q&A box, and we'll let some questions accumulate. Then we'll turn it over, and we'll go through some audience questions. But for now, maybe I'll start the Q&A just to get the ball rolling here. I want to ask about something in the last part of your talk when you were talking about mitigation efforts, and you mentioned that when it comes to cities, we have to reduce the trapped and absorbed heat. And that to me would imply less density in cities, or at least more moderate density, I think. But then we have to also lower anthropogenic heating, which requires a more walkable city, more public transit, and that implies higher density. So how do we reconcile those countervailing tendencies or movements towards density in those two strategies?
Yes. So we observed that some of the moderately dense areas had a better performance in terms of temperature. I mean, they were not warming up during the day so much and not so much of warming during the night as well. And so we'll have to look for those optimum densities which we can call as walkable or can be dealt with non-motorized vehicles. Plus, they are good for temperature, extreme heat as well. So there is that one particular sweet spot where we can get both the things on our plate.
Okay, good. Okay. What kind of resistance did you face when you first started working with groups outside the university, and especially with cities? Cities not only, there times can be like a distance between university research and what's happening in cities more practically, but also cities themselves and city governance can be very, very complex and complicated with, competing sectors. And you've mentioned we have to take a multidimensional, multifaceted approach. So what's the big challenge there? What pushback have you received?
So, I mean, we have had a lot of interaction with people and with the local agency. Initially, I would say that it was considered as a public health issue only. But in India, annually we have a workshop on extreme heat. And many local agencies attend these workshops. States also conduct these workshops. So there is a lot of awareness about it now that heat wave has more to do than just the public health. But yes, it is very difficult to convince people that you need to go beyond public health. So we have a study where it shows how the energy consumption varies with respect to these areas, and how in that ultimately it will affect the energy bill that you have to pay if you're living in a particular area. So sometimes I used to kind of use that study to emphasize on the impact of extreme health on other sectors as well.
Okay. Mm-hmm. So you kind of raised something else in my mind, and something I thought about during your talk, which is about messaging and communication. And you mentioned like heat warning systems and things like that. Tell us about the importance of messaging and communication. What are you trying to communicate to different groups when a heat event is occurring? And what kind of actions are you expecting?
So there are, various categories when you are giving a message. So you are giving a message to a common public, you're identifying vulnerable population, you're also identifying schools, identifying sectors that will be affected, like schools, the informal sector, the construction industry, the manufacturing industry. And you kind of list down a message that you have for each one of them. And then in some cases, you just kind of telling them to make some behavioral changes. Don't go out and drink a lot of water, a lot of fluids, stay covered, cover your head, those kind of things. And in certain cases where you know that people are vulnerable, for them you have a different kind of message to be told. So the public health department of the municipality essentially gets involved in the communication plan. And for the industry, you can ask them to change their working hours. The same thing is true with construction industry or schools. So for each affected, or each stakeholder rather, I would say the messaging is different.
And now I want to bring up something else you mentioned in your talk. You mentioned several times about the need for long-term urban planning. Can you kind of tell us a bit about that? What kind of expectations you have? What would you expect to see in a long-term urban plan to try to mitigate and adapt to heat emergencies in the future?
A couple of things that we are trying to work on as to one is around the green infrastructure, as to what kind of impact the green infrastructure has on the surrounding areas. What is the cooling potential of that green infrastructure? That's one, because that's a major mitigation measure that we know of. Secondly, the second part that we are trying to work on is what is the impact of morphology, urban form, on the temperature? And how do you balance the two things? One is the density of urban form and the required vegetation density ratio. And what is that optimum that you require to have the least minimum increase maybe in temperatures? So that's something that we're trying to work on currently. But there are multiple measures, like how can you integrate the public transport? One could be dedicated to transportation. The other could be dedicated to just water resource management. I don't know. I have not seen, because I've seen in Europe, you have fountains when there is a heat wave. You cannot imagine that in India because the water is not available, right? And a large part of this world has a water stress during summers. So water will have to be looked at very critically and will have to be planned properly. So there are multiple domains of urban planning itself that would require a detailed investigation. Rather, I would say a lot of research is also going on, but that is not getting translated in practice or in policy. That requires some amount of generic understanding or converting it into a generic model and then taking it to the pilot level maybe, and then finally converting it into a policy. So it will require a lot of effort.
You make that last part sound easy, but that sounds very difficult. I mean, what how do you bridge that gap? How do you translate that type of scientific knowledge into actionable policies?
Uh, I mean, typically scientists are, I guess, extremely happy in their own comfortable zones, working isolated on the projects. But in this, when we were preparing this heat action plan, we tried to, I would say this is our first step towards converting the study into some kind of measurable plan or policy. So then you talk to policymakers, try to make sure that whatever you are doing gets converted into a generic model kind of a document and not take the jargon of research when you're converting it into a policy. So that's something that we try to maintain. And I think that is an effort that researchers will have to make.
Yeah, okay. Yeah, good. I know we do our own community engagement research here at Ohio State, and it is challenging. You have to take a long view. You have to have patience, and you have to build trust before action can follow. And that's something that takes a lot of effort and takes a long time.
It took us 12 years to reach a place to at least make a small document, which can be now submitted, maybe reviewed. So it takes a lot of time and patience.
Exactly.
Yeah.
Okay, so we have a couple questions in the Q&A, so I'll turn it over to Jordan Swain-Fox, who will handle those. And if anybody else wants to submit questions to the audience, go ahead. There's still time, please.
Great, thanks, Harvey. So one question from the audience points out that types of buildings and their density play big roles in heat hazards. How do different types of material play into this? Do certain concretes, brick, or maybe wood have different results?
Yes. So in one study, we had also kind of taken thermal mass as one of the parameter of the morphology, and it does play a role in the sense how much heat it would absorb and how long it would retain would play an important role in in knowing whether it will get heated up during the day or it will start releasing the heat at night. But we only looked at the thermal mass. And the other thing that we were trying to see was the albedo, which I think fits really well in this particular context. Albedo does play an important role in modifying the temperature. And higher the albedo, lower the temperature. So we had I didn't put that slide in this presentation because there was only 30 minutes that we had. So, but there is a certain relationship between vegetation density ratio and the albedo, and albedo does play an important role in modifying the temperatures. They do. How realistic or possible or affordable is it for cities to collect the dynamic data recommended for this type of planning? Yeah, I think it is possible in the sense we already have, there is a lot of automation happening when you want to collect taxes, when you want to, supply electricity, when you want to, when you're talking about water bills and other things. If it can be integrated with that, and every time you get in my opinion, it is possible. Only thing is you will require a kind of a platform and a good team in place to start it maybe somewhere. We were trying to do this on a pilot basis. If we are able to do it, I think I'll let you know that we are working on a dynamic data platform.
Okay, we're getting toward the. I'm sorry. Go ahead.
I think I answered that question, right?
I think you did. Yes.
Yeah.
We're getting towards the top of the hour, so maybe we just have time. Maybe I'll just throw out a couple more questions in the last few minutes. So, you talk about this being hyper-local. Down at the neighborhood level, also cities themselves. Do you see value in urban system, looking at systems of cities, looking at cities all around the world, and collecting data, doing comparison. I mean, is there some value in that, or is this something that should be done? The research and mitigation should be done purely at a local level?
Should be done to understand, because I don't think you will require this hyperlocal is required, but you don't require to collect data for each city. There will still be a possibility of clubbing few cities together into a kind of a group where their behavior is similar. And you can have a model for that particular class of city or group of city. And collecting data from all around the world will certainly help. I think there are certain, like Budapt is trying to do, where LCZ mapping is going on. There are certain platforms where a lot of city level data is being collected from all over the world. And people are looking into what kind of patterns you get of LCZ mapping. But one can go further and get more data and have a collect the whole thing together to find out as to whether it is possible to group some of them together and have solutions prescribed for each group. I think it'll work. It'll be a good idea.
Right, I'm seeing that in urban science in general, that there seems to be like a movement towards massive city comparison using data,
yes.
and trying to come up with standard typologies and the type of how urban form develops, how urban development occurs.
So
and it seems like
so that could be a kind of a framework given for a particular group of type of city, and then the city itself can take up that as a framework and can modify it for its own implementation. I think that is how we should go ahead. Not, waste our energy in studying each city and going ahead and everybody is doing their own business. We need to come together and collect a lot of data and solve problems which we think can be collectively solved.
Right, and that can certainly help accelerate progress. And as we know, the heat is coming, and it's coming quickly. So we need to be moving forward very quickly.
Very much.
Okay, we're just about out of time, so I think we'll wrap things up. I want to thank you very much for an interesting talk. Thanks for joining us. And this reminder to our audience that this seminar series is continuing in spring 2024. I want to remind you that on March 1st, 12 to 1 Eastern Standard Time in the United States, we will have Dr. Matilda van den Bosch, who's a senior researcher at the Barcelona Institute for Global Health in Spain, and she will talk about urban green spaces for climate change mitigation and health co-benefits. So see you then. And again, thank you to our speaker today, and everyone, please take care and be safe out there. Thank you very much.
Thank you. Okay. Good night. Bye.